particles will move out of the page. They experience a force that will make them move out of the page. And we have said the reason is the first finger points to the direction of the field, second finger points to the direction of the current, thumb predicts the direction of motion. So meaning that since these are electrons, current will be moving the opposite direction, field will be pointing down, then the thumb is telling us in which direction. So the thumb will be out of the page. Now, if you are told to draw magnetic fields around this kind of diagram, this means current is going out of the page. Current is coming out of the page. When you see a dot, it means that current is coming out of the page. So, but since this is a conductor, the meaning fields are concentric circles around the conductor. Fields will be in correct concentric circles around that conductor. But now we need to predict the direction of the magnetic field because magnetic fields also have direction. So meaning that since this is current coming out of the page, then we are going to use right hand grip rule. You assume that you are gripping this conductor. So meaning you pretend that you are gripping this conductor that is coming out of the page and the current is flowing out of the page. So right hand grip rule means that if you grip a current carrying conductor like this, yeah, so the fingers carry around the conductor, you grip it like that, then these fingers here will predict the direction of the field. These fingers, these ones, will predict the direction of the field, but the thumb points the direction of the current. So assuming that this current is coming out of the page, and if I grip it like that, it means this thumb will be pointing towards me. And then if I assume I'm gripping this conductor in that direction, such that the thumb is pointing out, meaning current is coming out of the page, then it means fingers here will predict the direction in which the fields will be moving. So meaning that our field will be moving in that direction. Let me just so this we are going to predict the direction of the field. They will be going in the anti-clockwise. So meaning that here we shall have this way, this way, this way, this way. Coming down, we'll be moving that way, that way, that way, and that way. Right. But for this part here, it means that current is going into the page. When you see a cross, it means current is going into the page. But the pattern of the magnetic fields of the electric field around a straight current carrying conductor is also concentric circles around the conductor. So what we shall use right hand grip rule for is to predict the direction of the field. So this current is going out, so the thumb should point into the page. This thumb will point into the page, and these fingers here will tell you the direction which the field will be pointing, the direction in which the field will be pointing. But the thumb will be pointing into the page because X means current going into the page. So meaning that if I use right hand grip rule, I'm going to have my fields pointing in that direction. On the other side, they'll be moving up like that. So that is how you be able to use right hand grip rule, Fleming's left hand rule to determine the direction of motion of alpha particles. And then you are going to also have something we call a motor. When current flows through a conductor and this conductor is placed in a magnetic field, also you are going to use Fleming's left-hand rule to predict the direction of flow of the current. So something that you need to realize at this point is that as much as we are having this magnet here, the magnet have magnetic fields in that direction. These are the magnetic fields of the permanent magnet. So how is a force produced? So something I want you to remember at this point is that when current flows through a conductor, magnetic fields are created around that conductor. And since the magnetic fields are created around the conductor that is carrying current, then it means when those magnetic fields created due to the flow of current interact with the magnetic fields of this permanent magnet, then it means that a force is going to be created. And this force will depend on the amount of current and the strength of the fields of the permanent magnet. Now, how do you predict the direction in which AB move and the CD move? Now, you see the fields are pointing from the north to the south. So we're going to use Fleming's left-hand rule. The first finger points the direction of the field, second finger points to the direction of the current, the thumb points the direction of the motion of the conductor. So for instance, if I'm considering AB, current moving DC, B, A, then my current is going from A to B. So I put my finger like that, the first finger like this, such that it's pointing the right direction in which current is going. And this finger here is pointing the direction in which the fields are moving. Fields are moving from north to south. So when I'm placing it like this, yeah, this is current finger pointing that direction, field that direction. You can see the thumb is pointing upwards, is pointing out of the page. The thumb is pointing out of the page. So meaning AB will experience upward force, that is AB, and the CD will experience a downward force. So this one will be coming up. Is going to this one will be coming up as this CD is going down like that. So using Fleming's left-hand rule, such that this first finger points to the direction of current of the conductor, fields points in that direction, and the thumb is pointing out. So meaning this is going to rotate in that direction. So some of the factors that determine the amount of the strength of the force depends on number one, strength of the fields, that is the strength of the field of the permanent magnet, and also it depends on the amount of current.